In this video, we will be discussing how to calculate the surface area of a variety of different circular solids. The first circular solid that we are going to take a look at is a cylinder. A cylinder contains two circular bases, and we're going to look at this bottom base and call this the radius of our base, and then this side here is going to be the height of our cylinder. Now, because this is kind of similar to a prism, the lateral area of a cylinder is actually going to be the same formula as that of our prism. So it's going to be equal to the perimeter of the base times the height. Same thing with the total area then. Because there are two bases, it's equal to the lateral area plus the area of two bases. Now let's kind of talk about why this is and where this formula comes from. So I like to think of cylinders as soup cans. And if you think about the label around a soup can, if you were to unravel that label of that soup can, you would have a rectangular shape. If you don't believe me, go ahead and grab a can of soup and take that label off. And then, so this would give us, this rectangle here would give us the lateral surface area of our cylinder, so not including those two bases. And the height of this rectangle is going to be the same as the height of the cylinder when you go to unravel it. Now to find the other side of the rectangle, that is going to be equal to the circumference of the base. And recall that the circumference formula of a circle is equal to 2 pi times the radius. So if we think about our formula that we have up here for lateral area, we have the perimeter of the base times the height. Well, what is the perimeter of this base? The perimeter of the base, since it is a circle, is going to be equal to 2 pi r times the height. So that's where that lateral area comes from. Now to find the total surface area, we have those two circular bases. They would be somewhere around here and here. So to calculate the area of those bases, so the area of a circle formula is equal to pi times the radius squared. So I like to think of it as these formulas, but you could also think of it as, instead of writing out perimeter times height, you could actually write out 2 pi r times h. I think it's easier to go with this formula because then it's the same as the formula for a prism. And then you could also think of the total area formula as 2 pi RH, oops, sorry, I forgot the R up here, RH plus 2 times the area of the base is pi times the radius squared. So that's another way of thinking of those formulas. Now the next circular solid that we will be discussing is a cone. For a cone, again, there is a circular base, and we'll call that the radius. The slanted side, we know that that vocabulary word is the slant height. We usually use a cursive L to represent that. And then this is the height of our cone. So a cone is similar to a pyramid that we've discussed because it contains only one base. Therefore, the lateral area formula is the same as that of a cone, which, recall, that formula is equal to the perimeter of the base times the slant height divided by 2. Then to calculate out the total area, we would take the lateral area and add the area of just one base, since a cone has only one base. Now let's think about if we were to unravel that cone. What shape would we have for the lateral surface area? The shape that we would get is actually going to look kind of like a sector of a circle, where this distance is equal to the length of the slant height, and the arc length of this sector is actually going to be equal to the perimeter of the smaller circle, the base of the cone. So that would be equal to 2 pi r. So again, recall that the perimeter, to calculate out the perimeter of a circular base, we would use that circumference formula, 2 times pi times the radius. And then if we multiply that by the slant height and divide that by 2, that's how we calculate out the lateral surface area of a column. Also, don't forget to calculate out the area of this base. Since it is a circle, we're going to use the formula pi times the radius squared. So again, these formulas are very nice because they are the same exact formulas that we've already covered in previous sections. Now, to calculate the total area of a sphere, this is a little bit different, this formula here. A sphere is a very unique three-dimensional shape because it does not contain any bases. Therefore, there is only one formula to calculate the surface area of a sphere. So we'll just say the total surface area of a sphere is equal to 4 times pi times the radius squared. Now I'm not going to derive this formula for you because it actually gets a little complicated, and rather than confuse you, I think we'll just stick with the formula for what we're going to be doing in this class. The radius is just the distance from the very center of the sphere to the edge of the sphere. Now, if we think about a hemisphere, what is a hemisphere? It's half of a sphere. And a hemisphere has a lateral surface area and a total surface area because it does contain one base. So to calculate out the lateral surface area of of a hemisphere, since it is half of a sphere, it's going to be half of the sphere formula. So 2 times pi times the radius squared. To calculate out the total surface area, you're going to take the lateral area of your hemisphere and add the area of one base. Now, sometimes some people like to think of this formula as 2 pi r squared, that would be the lateral surface area, plus the area of the base would be pi r squared, and we can simplify this to 3 pi r squared. So that's another way. Whatever way you feel is easier for you to remember, if you just want to remember it like this, or if you want to memorize it like this. Either way. Again, the radius would be this distance here. So now that you have all these different formulas, I want you to try to apply them to the examples on the back of your notes. After you've tried them, go ahead and move on to the next video to check your answers to see how you did.